All right, so now we're in section 3.5, and so we're putting together exponential and logs, and we're going to be solving equations, so solving for a variable like x. All right, so what we're going to do is put together all of the things we've learned, everything we've learned about logs and their properties, as well as exponents and their properties, and how to go back and forth between exponential and log form. We're going to do all of that to be able to solve these equations. All right, so first things first, let's talk about exponential equations. That's the first thing here. And we're going to use this equivalence property to answer these questions. So we've kind of seen something like this before. All right, so if we have b as our base, so b to the x equals b to the y, these are both exponentials, variables at the top. That implies, since we have the same base, it implies that the exponents are the same. And so that's going to be our technique that we're going to use at first. See if we have the same base, see if we can create the same base, and set the exponents equal to each other. So for number one, solve the following exponential equations. The first one is 3 raised to the 2x minus 6 equals 81. All right, so notice on this side we have a base of 3. On this side we have a base of 81. So we want to think, is there any way that we can rewrite 81 as 3 raised to a power? And we can. 3 to the 4th, so we can check our calculator. 3 raised to the 4th is 81. So when I write this problem, 3 to the 2x minus 6, I'm going to let the right side equal 3 to the 4th because that is the same thing as 81. And now we have the same base, so we can use this equivalence property that says if we have the same base, we can just set the exponents equal to each other. So we have 2x minus 6 equals 4. And this is definitely an equation that we know how to solve. All right, so we're just going to solve for x. So I'm going to add the 6 to both sides, divide by 2, x equals 5. And if you are unsure, you can just check. All right, so with all of these equations where you're solving for x, it's very helpful if you go back and check your answers. All right, so let's plug in 5. All right, so this is 3 to the 10 minus 6, 3 to the 4th. We already discovered 3 to the 4th was 81. Both sides are equal. We were correct. X equals 5 here. Okay, now let's look at part B. So 25 to the 4 minus t equals 1/5 3t plus 1. So here we're trying to solve for t. We would love to get the same base on both sides. So can anyone see a candidate for a good base that we could have? So this one's 25, this one's 1/5. I think 5 would be a great base to have. All right, so we can rewrite 25 as 5 squared. So now we have 5 squared raised to the 4 minus t. All right, and on the other side, how can we write 1/5 as 5 raised to the power? Well, that's 5 to the negative 1. All right, and so 1/5 was being raised to the 3t plus 1. All right, so we still have a little bit of work to do. So remember those exponential properties when we have a power and then we're raising to another power? That means we need to multiply. So I have to distribute this 2 here. Same on the other side. I need to distribute this negative 1 over here. So now we have the same base, which means we can set the exponents equal to each other. All right, so I'm going to move my t's to the other side. So I'm going to add this 3t to both sides. And also at the same time, I'm going to move this 8 over here. So I'm going to subtract the 8 from both sides. All right, so that's going to be 0. That is going to be a positive t. And then over here, we're going to have a, oops, this was a mistake. This should be a minus. So minus 1 minus 8 gives us a minus 9. So we get t equals negative 9. If we are unsure, because that was a long process, we can check our answer. All right, so we have 25 raised to the 4 minus negative 9 equals 1/5 raised to the 3 negative 9 plus 1. All right, so we have 25 to the 13th. Yeah, that's positive 13. And then we have 1/5 to the negative 26. Well, let's check this out in our calculator. Make sure they're right. All right, so 25 to the 13th is this big number, 1.49 something. Can't see because my calculator is messed up. 1.49-ish. And then if we do 1/5 raised to the negative 26, we get the same thing. So great. These are equal. Our answer, t equals negative 9, is correct. All right, now let's talk about what if that doesn't work? What if we can't get the same base on both sides? What do we do? Well, we have these steps to solving exponential equations, and our trick is we're going to use logs. So we already know how to go back and forth between exponential form and log form. So that's exactly what we're going to do. So step 1, we're going to isolate the exponential expression on one side of the equation. So we're going to get the exponential by itself. And then we're going to take the log of both sides. So you could either take the log of both sides or you could rewrite in log form. It's up to you. And then use the power property of logs to bring down the exponent. And then we're going to solve the resulting equation. All right, so I'm going to start the next example on the next video so this doesn't get too long.